Hello students, I welcome you all. Myself Dr. Dhirendra Shukla, Associate Professor in Department of Engineering Mathematics at Technocrats Group of Institutions. Today we are going to discuss about matrices, which is a part of Engineering Mathematics Level 1. So first we start by the definition. So what is the definition of matrix? A system of mn numbers which could be real or complex arranged in a rectangular array of m rows and n column is called a matrix of order m cross n. It is also called m cross n matrix. You can see here there is a matrix A equals to under the bracket. So here row wise you can see A11, A12 up to A1n. In the same way the last row is AM1, AM2 up to AMN. The order is here m cross n. So this is the definition of matrix. So this slide is a recapitulation part which you have already studied in your school education. So there are a number of type of matrices. So first we go for horizontal matrix. So the type of matrices we can understand according to the relation between row and column. So when m is less than n, so that is called horizontal matrix. In this case, you will have number of rows less than number of columns. In the same way, vertical matrix, when m greater than n, in this case, you will get number of rows more than number of columns. So there are some other definitions like row matrix. So here you will have only one row, but number of columns can be there. Similarly, in column matrix, here you will have only one column, but number of rows will be there. Null matrix. Null matrix is the matrix where all elements of the matrix are 0. Here it doesn't matter the matrix is horizontal or vertical or any another order. In general way, we use it the null matrix. But if somewhere it is required, so you can classify it also. Now diagonal matrix. If you have a matrix in which there are only elements in diagonal and rest of the elements are 0, so such kind of matrix is called diagonal matrix. Then scalar matrix, which is a case of diagonal matrix where all elements of diagonal are strictly similar. As you can see here, the matrix is K00, 0K0 and 00K since all elements are same. So this is called scalar matrix. And when you pick the element k as a common element, so you will get strictly 1 in diagonal. So such kind of matrix is called unit matrix. So unit matrix can be order of 2, order of 3 and other higher order also. Then triangular matrix. Triangular matrix can be divided in two parts, upper triangular matrix and lower triangular matrix. So when you have a square matrix and there are elements above the diagonal, then it is called upper triangular matrix, and you have elements below the diagonal, then it is called lower triangular matrix. In the same way, equal matrix, when elements are same place by place, suppose there is a matrix whose elements are associated and explained by Aij, and the same element type of matrix B equal to Bij, then Aij equal to Bij if the elements are same place by place. So such kind of matrix are called equal matrix. So here you can see addition and subtraction, the process you have already studied in school education. So it is here for recapitulation. For this portion you can pause the video and see the formulas. For your concern, I can say you that addition and subtraction is possible in matrices for the same order of matrix. Two different order matrices cannot be added and subtracted. Clear? So here is one example for understanding the addition and subtraction process. The next is matrix multiplication. Matrix multiplication is a very important process in matrix. When you have to multiply two matrices, then you have to make sure that the order of first matrix should be m cross n and the order of second matrix should be n cross p. In this case, the multiplication in between two matrices can be possible. There are some properties and one example is there to understand the process. Here I can tell you that matrix multiplication is not commutative, sorry, is not associative. So you can see here associative law and commutative law and distributive law. So matrix multiplication is not commutative, means A multiplication B is not equal to B multiplication A. One example is mentioned here. Then another properties and definitions are here. So you can see here, and it is the recapitulation part which is already you have studied in the school education. So how can we multiply the more than one matrix like A, then A dot A, then A dot dot A. So in power method you can say it A square, A cube, and so on. Clear? Here are some more examples. So to see these examples, you can pause the video and note down the content in your copy and read out the materials. So now we can go for the required part of the matrix. The next topic, what is the matrix? Rank of the matrix. So when we go for the rank of the matrix, the rank of matrix is basically known as number of non-zero rows in a given matrix. There are several methods to find out the rank of the matrix, in which first method is echelon form of a matrix. When we have to form the echelon form of matrix, so we have to operate row operation, in which we can create zeros in a matrix in ascending order. Here first element should be non-zero, then in second row first element or more than one element could be zero. In another row the number of zeros should be higher than the previous row. So by continuing this process we can get echelon form. If after 0 the every first non-zero element is 1, then it is called perfect echelon form. So here you can see the example, find the rank of the matrix. So you can see here the first row is 1 2 3, then 1 4 2, then 2 6 5. So here we apply the row operation by taking the first row first element 1. So the operation are R2 in place of R2, that is R2 minus R1, and the same way in place of R3, R3 minus 2R1. So we have to make the operation according to the requirement of the matrix. So we can see after the making operations, the last row is completely 0, and in second row there is first element is 0. So then it is a echelon form. So to find out the rank of the matrix, we have to count total non-zero rows. So here we have total 2 non-zero rows. So rank of the matrix is 2 here. And another topic is nullity. How to find a nullity? So if we have a square matrix, then your nullity is order of matrix minus rank. So here order of matrix is 3 and the rank is 2. So 3 minus 2 equal to 1. That is the nullity of the matrix. There is another example to find the rank of the matrix. You can see here the elements are in square form, 1 square, 2 square, 3 square. So first of all I have to make the square form in the simple number form, that is like 1 4 9 16 and so on. Then again we have to follow the procedure. So here you can see the first row first element is 1. So by using this one we can create the multiple operations and we have to make the zeros in the preceding rows. So you can see here multiple operations are here. After going this process we can see there is a last matrix. There you can see the elements are 1 4 9 16, then 1 0, then 1 4 9, then 2 times 0, then 1 3, then last row is completely 0. So again you can see here the total number of non-zero rows are 3 here. So the rank of the matrix is 3, and I told you the nullity of the matrix is rank of matrix minus order of matrix minus rank of matrix. So that is 4 minus 3 equals to 1. So this is the way to find the rank of the matrix. Now we go for the solution of simultaneous linear equation. So in this case we have a number of equations in 2 variable or 3 variable or etc. So how can we find the solution in such case? So this is the definition portion. So if we have an equation like a11 x1 a12 x2 and so on equal to b1, so we have to make this set of equation in 3 parts. The first part A is called matrix A, which is created by the coefficients of the variable in row manner. Then second is column matrix X, which is for variables or unknowns. In matrix we can say it unknowns. and the third is column matrix B, which is for constant part, that is usually numbers. So there is again the theory part which I explained you, how can we create the matrix. Now augmented matrix, when we have to make argumentation in between two matrix, so we have to basically join two matrix by a argumentation sign. So here our matrix are joined by in parallel of rows. So first you have to mention matrix A completely, then is a partition line, then after matrix B. So in that case you will increase in column by 1. So you can see here order m cross n plus 1. Now to find the solution of simultaneous equations, there are some cases. So when you have the solution, when you don't have the solution, so there is two words, consistency and inconsistency. If rank of matrix A is equal to rank of augmented matrix A augmentation B equal, then we have a solution. And if rank of A not equal to augmented matrix rank of A augmentation B, then there is no solution. Clear? So again we have to understand this by a suitable example. So here one example, so that the following equation are consistent. So equations are there. First we have to create A, X and B. A is for coefficient elements of matrix, then X is for column matrix for unknowns, and B is column matrix for constant numbers. So we have prepared argumentation matrix A augmented B. Again we have to make operations, row operations. So here we try to create the again echelon form. So in last we have to compare the matrix rank of the matrix A and the rank of the complete matrix A augmented B. So here are so many operations you can see here. After completion the operation in last row, you can see argumentation A augmented B, 1 minus 1 2 0, then 0 1 2 1, then 2 0 minus 4 minus 1, 3 times 0 then 1. So you have a partition line here. You can see the rank of A part only, means the third three columns of front, last is for B. Okay, so you can see here the for three columns of from left hand side, there is the rank of the matrix A is 3, and for overall there are 4 number of non-zero rows. In A there are only 3 non-zero rows, and in complete there are 4 non-zero rows. So you can see here the rank of A is 3 and rank of A augmented B is 4. Both are not same, so system is inconsistent. In the same way another example is there. So we have to create A, X and B. Then we have to make operations here. After making the operation, we can see at last that in A part, total number of non-zero rows are 3, and the incomplete there are also total number of zero rows are 3. So rank of A is equal to rank of A augmentation B. So that is 3. So the system is consistent, and in this case we can get the solution. So by taking A augmentation we have to create the equations. Here you can see. So there are two equations, x plus y plus 2y plus 3z equal to 14. Another one is y plus 5z equal to 14 and 17, and the last one is z equal to 3. So by putting the value of z equal to 3 in second equation, we get the value of y, and similarly by putting the value of y and z equation 1, we get the value of x. So here are few another examples. So you can pause the video and see the example and with solution, and you can also practice these questions on your copy. So these are several examples to understand the topic. Now we have to understand the another topic, that is to find matrix polynomial. We have to get matrix polynomial. So what is matrix polynomial? If we have a polynomial where we can write it f lambda is equal to a naught plus a1 lambda plus a2 lambda square up to a and lambda to the power n, where lambda is known for unknown and a naught, a1, a2 up to an are matrices. Such type of composition is called matrix polynomial. So by this we have to create characteristic matrix, that is A minus lambda I. In this case, the elements of diagonal will be written as A11 minus lambda, A22 minus lambda up to ANN minus lambda. Again, then characteristic polynomial. So we have to consider determinant A minus lambda I, that is the characteristic polynomial. And to make characteristic equation, determinant A minus lambda I equal to 0. In this case, we will get an equation in lambda. After making the solution of this equation, we will get the values of lambda, and such values of lambda are called eigenvalue. For each and every value of lambda, there is a unique solution that is called eigenvector or characteristic vector. So to understand this, there is an example. A equal to 5, 4, 1, 2, that is a matrix. So first of all, we have to create A minus lambda I. That is, you can see here A minus lambda I is equal to 5 minus lambda, 4, then 1, 2 minus lambda. By making the small solution, we can get the value of lambda, that is 1 and 6. So these values are called eigenvalues. Similarly, a few more examples are here. So here you can see again the value of lambda is 1 and 3. These are called eigenvalues. So another question is find the characteristic values and vector. So the matrix is A equal to 8 minus 6 2 minus 6 7 minus 4 2 minus 4 3. So first of all we have to create determinant A minus lambda I. By making the solution, we can get the values of lambda. The values of lambda are 0, 3 and 15. By taking one by one for each value, we can get the eigenvector. So first of all, I have taken lambda equal to 0. So according to the equation, we have to put the value of lambda A minus lambda I x equal to 0. So by making again row operations, we have to reduce the matrix. After reducing this, we will get the equation. So here we get the equation 2x1 minus 4x2 plus 3x3 equal to 0 and x2 minus x equal to 0. So when we have total number of equation equal to the total number of unknowns, so it is easy to solve. And just like previous example, here we have x, y, z 3 variables and we have the values for all values. But when in this case we have three unknowns x1 x2 x3, but we have only two equations. So in that case we have to consider any one unknown in the form of k. So you can choose any one. So here I have chosen k. So x3 equal to k, then we get the value of x2 in terms of k. By putting the value of x2 and x3 in terms of k, we get the value of x1 also. So by putting x1 is equal to k by 2, then k and k, we can keep the k as a common value. So that is 1 by 2, 1 and 1. So this is the eigen value of the matrix for lambda equal to 0. In the same way, we can calculate for lambda equal to 3 and lambda equal to 15. So the process is complete mentioned here. So you can pause the video and you see the process also. So next topic is Cayley-Hamilton theorem. It is a very important theorem, Cayley-Hamilton theorem, by which we can find out the inverse of the matrices. So in the same way, here we need to create the characteristic equation also, and the Cayley-Hamilton theorem states that every square matrix satisfies its characteristic equation. So we will understand this by an appropriate example. So how can we satisfy the Cayley-Hamilton theorem? So the example is there, so that Cayley-Hamilton theorem is satisfied by the matrix A. So how can we determine it? So there is a matrix A. First of all, we find out determinant A minus lambda I. You can see here. Then after making operations, we can get an equation. The name is equation number 2. So just above the equation number 2, you can see the expression here in terms of lambda. So as you know, Cayley-Hamilton states that every square matrix satisfies its characteristic equation. So we replace the lambda by A, and by putting the values of all A square, AQ and so on, you can see here the left hand side and right hand side both are same, that is 0. So you can see here A square, AQ, and put the values of these terms in equation number 2, and at the last you can get left hand side and right hand side both are same, that is 0. So now we have to find out the inverse of the matrix. So how can find inverse? So multiply the equation by A inverse. So you can get a term by with A inverse. So you have to keep the A inverse in left hand side and transpose all the elements in right hand side, and again to put the values of I, A and A square and any term which is want, and then make the matrix calculation like multiplication and addition, subtraction, etc., and then you will get the value of A inverse. So this is the process of Cayley-Hamilton theorem. Now the next topic is diagonalization of matrix. It is another important topic, diagonalization of matrix. In case of diagonalization of matrix, we find a similar kind of matrix for a given matrix A, which is a diagonal matrix, and it contains the elements in diagonal also. So how can we follow the diagonalization of matrix? So there is an example. So first of all, we have to create determinant A minus lambda I and we get the equation in terms of lambda. So when we get the value of lambda, so first of all we have to find out the eigen vectors. So lambda equal to 1, 2, 3 are eigenvalues. Then by one we will get the value of eigen vector. So first of all we have taken the first term lambda equal to 1. Then there is a process, so we will get the value of x1. Then the process repeat for the next of the two values, so we will get the another two eigenvectors. So when we get the eigenvectors, so we have to create another matrix named as P is equal to x1, x2, x3, and put all the eigenvectors here in the column manner. Then find out its P inverse by any suitable method like Cayley-Hamilton theorem. So we have to find out the P inverse. You can see on screen the value of P inverse, and then you have to consider another diagonal matrix known as D and written as P inverse AP. So there are three matrices P inverse A and P. Make the matrix multiplication in between and you get the result. You can see here 1 0 0 0 minus 2 0 and 0 0 3. You can see here there are only elements in diagonal and rest of the elements are 0. So this is called diagonalization process, and the result is called diagonal matrix. In this question we have to also find out the a to the power 4 of the given question, means given matrix A. So how to find it? So first we have to find out d to the power 4. In case of diagonal matrix, when you have to find out multiple powers, so you can just put on the power on the elements of diagonal. So find out a to the power 4, that is p d to the power 4 P inverse. Again follow the procedure of multiplication and finally you will get the answer of a to the power 4. This is the complete process of diagonalization. So by this I hope you have understand all the topics of the unit, and there are few examples also mentioned in the video. So students, we discuss about the matrices as the content given in the unit. So that's all for today. Now we will meet in next lecture to discuss another topics. Thank you. Have a nice day.